Everyone, today I'm going to give a presentation of the introductions to classification matrix, ROC and AUC. To begin with, we need to introduce what is ROC and AUC. ROC simply represents receiver operating characteristic, and ROC curve is a graph showing that the performance of classification models at different thresholds. Well, from the graph here, as we can see, all the color lines represent the ROC curve. And AUC simply represents area under curve. And the curve here means the ROC curve. In this presentation, I'm going to use logistic regression as an example to show you how to generate ROC for model. Remember what is a logistic regression? We use it for classification for binomial outcome. Well, let's assume we are a company who would like to investigate the potential customer for our products. So, given a data set, we would like to fit our data points into our logistic regression models, and then we will get outcome probabilities between 0 and 1. And next step we are going to do is we need to choose a threshold, let's say 0.5. And then we will decide the classifications. The threshold will sort the data into two different sorts: customer who like this product and customer who dislike this product. Well, immediately by looking at this graph, we notice our model is not 100% accurate because the point A, B, and C didn't get correctly sorted. Well, then we find by moving the thresholds, our classification results could change. So how do we measure the moving thresholds effect? We introduce ROC here. Well, but before we connect our models to ROC, there is one more step we need to do. We need to store the moving thresholds results for our classification model. That's why we introduce confusion matrix. Confusion matrix is simply a matrix includes the true values and the predicted value of a model. By moving the thresholds, we can see we will get a different confusion matrix for each threshold. And those confusion matrix will be directly used to generate ROC point. So how do we do that? Well, before we get to that point, there's two more things we need to introduce. The first thing is the true positive rate. True positive rate is a conditional probability. Well, let's say given the data point is positive, what is the probability that the model will classify it as a positive data point? And the next thing is for positive rate. It's also a conditional probability that given the data point is actually negative, what is the probability that the model will classify it as positive? We certainly want larger true positive rate and smaller false positive rate. And then we convert the true positive rate and false positive rates to a coordinate system, which we are going to use to plot the ROC. So from the confusion matrix, we can calculate the true positive rate and false positive rate. And this will become the X and Y value of an ROC point. By moving the threshold, we will get different confusion matrix and then generate different ROC points here. By connecting all the ROC points, we will get an ROC curve. So what's the value of the ROC curve? Well, usually ROC curve will help us to decide what thresholds will perform better. Now we get to AUC. As we mentioned, AUC simply means area under curve. In this case, it will be the green areas on the graph here. AUC are used to compare between multiple ROC curves. For example, given the same data set in our companies, we use a random forest tree models to fit the data as well and then get a new AUC curve. And the large AUC means better quality of classification. So in this case, we will prefer a logistic regression than a random forest tree model. To summarize, ROC is used to measure the trade-off between the true positive rates and false positive rates and then do the threshold selection. And AUC is used to measure the model performance and do the model selections between multiple models. I'm pretty sure we are going to get to know more in our following courses. So this is my presentation. Thank you for listening.